After inducing a stall, James Bond and the female hero bail out of the plane. He falls through the air above the Bolivian desert to avoid the captors trying to capture him. Most of the flight is a free fall, as it's a struggle for him to get to the female hero and deploy the parachute. He falls into a Bolivian sinkhole and then finally is able to struggle with the female hero and pull his parachute, slowing him just before he hits the ground.
Alright, the facts that we know. The plane is flying at 20 knots when James Bond jumps out of it. It is flying at a height of 853.44 meters in the air. And then the depth of the average Bolivian sinkhole is 314 meters. So that means the distance to the ground from his jump would be 1,167.44 meters. And James Bond falls for a total of 22.62 seconds. He activates his parachute for the final 2.10 seconds, which means he fell free falling for 20.52 seconds. And a parachute slows you down at 21 meters per second squared. And a human being can only survive at most a 50 meter per second impact. All right, now taking a look at what the acceleration due to gravity James Bond would have to undergo for him to fall 1,167.44 meters in 20.52 seconds, with his initial velocity being 0 meters per second. We plug all those numbers into our Big Four equation as seen here. Doing the math, we find that his acceleration due to gravity is 0.0132 meters per second squared, which is significantly lower than Earth's gravitational pull of 9.8 meters per second. So this is extremely inaccurate. Now, assuming that James Bond did fall on Earth with a gravitational pull of 9.8 meters per second, and he fell from a height of 1,167.44 meters, and the velocity initial, since he's jumping out of a plane, is 0 meters per second, what would his time actually be? Using the same Big Four equation, we plug in all the numbers, and we find that his actual fall time should have been 15.4 seconds, which is about 5 seconds faster than his actual time. So, this is, again, extremely inaccurate. Now let's take a look at what velocity James Bond would be hitting the ground at, considering all the variables that we've gone through. So he's on Earth, so the acceleration due to gravity is 9.8 meters per second squared. And its distance, again, is 1,167.44 meters in the air. Using a different Big Four equation, velocity final squared equals velocity initial squared plus 2 times acceleration times distance. We plug in all the numbers. His velocity final comes to be 151 meters per second. But taking into account his parachute opening, which slows him at 21 meters per second squared for 2 seconds, slowing him down 62 meters per second, he still would hit the ground at 88 meters per second. And as we all know, a human being can only survive an impact at max 50 meters per second. So James Bond, in this case, would be dead.